Hello everyone, welcome to Veteach. In this class, we are going to solve problems on hypocycloids and epicycloids. If anyone missed my previous video, that is introduction of cycloids, epicycloids and hypocycloids, go through the previous video, you will get a clarity difference between three words, that is cycloids, hypocycloids and epicycloids. Let's see the problems on epicycloid. Construct a curve traced by a point on a circumference of a circle, radius 30 mm. This radius 30 mm is the generating circle. This is R. Small radius circle is 30 mm, which rolls without slipping on the outside the circumference of fixed circle, radius 90 mm. In this problem, he has given two circles. One is the fixed circle and another one is the generating circle. Fixed one circle is the always it will be fixed, that is base circle, and another circle that is 30 mm, that is small radius, that is a generating circle. I will give a key point difference between epicycloids and hypocycloids. If the generating circle, we are having two circles in a epicycloids and hypocycloids. This is the fixed circle or base circle. We can call it as fixed circle or base circle. This is always fixed, and another circle, that is small circle, we call it as generating circle. Generating circle. If the generating circle rolls outside the fixed circle, then it is called as epicycloid. If the generating circle, that small circle rolls, see like this, if it rolls outside the generating base circle, it is called an epicycloid. If the generating circle rolls inside the fixed circle, that is base circle, then it is called an hypocycloid. Okay, this is the only major difference between cycloids and a hypocycloid. If the generating circle rolls outside the base circle, then it is called an epicycloid, and if the generating circle rolls inside the base circle, it is called an hypocycloid. In this question, he has given without slipping on the outside the circumference. Here I found a word outside, then it is a epicycloid. If the generating circle rolls outside the base circle or a fixed circle, then it is called an epicycloid. Then we have to solve this problem by using epicycloid method. See how to solve this epicycloid method. Okay, for every cycloid, that is epicycloid and hypocycloid, we will have a two circles, that is base circle and a generating circle. Base circle, that is given R, capital R, is equal to 90 mm and small r, that is 30 mm. By using these two circles, we have to draw the method of epicycloid. For both epicycloid and hypocycloid, we are having a common formula, that is theta is equal to small r by capital R into 360. Why we are using this formula is, for one complete revolution or for one complete rotation, we have to calculate the angle between curve starting path and the ending path. To calculate the angle between starting part and the ending part, we need to use this theta formula. Theta is equal to small r by capital R into 360. Small r given 30 mm radius, capital R 90 into 360. I got 120 angle. In this between 120 angle, I have to draw a curve of a path, that is epicycloid. Let's see how to draw this epicycloid method on a drawing sheet. Small r is given 30 mm and capital R base circle is 90 mm. First we need to draw the capital R, that is base circle or fixed circle. Draw a rough line. Okay, I am drawing a rough line, that is 90 mm base circle. This is the point P. Next, I want to draw the small circle that is radius 30 mm. This small circle, generating circle, rolls outside the base circle. Then I want to draw this 30 mm upon the P point. Why? Because generating circle always rolls outside the, if it rolls outside the base circle, it is a epicycloid. In the question, he has given the circle is rolling outside the fixed circle. Now I am drawing 30 mm radius circle, that is small r. See, this is the small r, 30 mm. It is a point C. Now from point C, I want to draw the small radius circle, that is generating circle, 30 mm radius. 30 mm radius, it is a 60 mm diameter. By taking 30 mm radius circle, draw a circle from point. This is the generating circle and this is the fixed circle. Now divide this circle into 8, 12 or 4 points, that is your wish. I am dividing this circle into 8 parts. For this I need to keep an angle 45, 45, 45, 45. By keeping 45 angle, you can divide the circle into 8 equal parts. Here I have divided the circle into 8 equal parts by keeping an angle 45 degrees. Now by using theta formula, I got an angle 120. Now I have to keep an angle 120 between fixed circle line. This is the 120 angle. Now generating circle rolls forward. Then I have to give the number, starting number from here, 1, 2, 3, 4, 5, 6, 7 and 8. Both 8 and P will be on the same point. Now by taking compass, trace all the points, okay, project all the points, 8. Both 1 and 7 will be coincide on same line. 6 and 2 will coincide on same point. From point O, you need to draw a curve, that is 8 point. 8 and P both coincide at the same point. From O, you need to draw an arc. By using compass, draw an arc from point 8, and 7 and 1 will coincide at the same point. Like this, you need to draw a curve for every point. Now in between 120, I have to divide this 120 into 8 equal parts. Why? Because the circle I have divided into 8 equal parts, then I have to divide 120 into 8 equal parts. By dividing 120 into 8, I will get a angle 15. By using protractor, divide this 120 angle into 8 equal parts, then I will get each angle 15, 15. That is 15, 30, 45, 60, 75, 90, 105, 120. Okay. Join all these angle up to C, center line. You have to extend this 15 degrees angle point up to C line, that is center point line. Extend all the 8 points. If you divide the circle into 12 equal parts, then you have to divide this 120 angle into 12 equal parts. This is the point C1 and second one C2, C3, C4, C5, C6, C7 and the last point this is C8. Now to draw the arc I need to take a distance from P to C. Taking distance from P to C and cut an arc from C1 to first point. This is the point I got, first point on a line, on a arc, first arc from P to C. Again take same radius C to P and cut from point C2 on second arc. This is second point, and from C3 cut a arc on C3 on third point, and from C4 you will get the exact top straight point. From C5 you have to cut an arc on fifth line. From C6 I got a point, this is C5 and this is the C6, and from point 7 I got a point here, and from point C8 this is the exact end point, this is C8. Now join all these points from point P. You have to join all these points starting with point P. Draw a smooth curve with a free hand. Take a 2H or 5H pencil. Draw a smooth curve with a free hand. This is not a fifth point. I got a point 5 here. See, this is the curve I got after one complete rotation. With a HB pencil and draw darkly on a smooth curve. This is the curve obtained after one complete rotation of a epicycloid. Okay, in the next class we will solve a problem on hypocycloid, that is inside the fixed circle is a hypocycloid. Keep practicing the epicycloid problem. We will meet in the next class. Thank you.